1h, we are asked to differentiate f of r equals the cosine of r times the arc cosine of r. So unusually we have r as the variable. Well, notice that we have a function here of r and then another function of r here, and these two functions are multiplied together, so we're going to want to use the product rule. Alright, so to find f prime of r, we'll have the first factor times the derivative of the second factor plus the derivative of the first factor times the second factor. Now, let's talk about this arc cosine of r. If y equals the arc cosine, and you know that that's just the inverse cosine of, say, u, then y prime is going to be equal to, that's a u, let me rewrite that so it's a little easier to read. Then y prime, it turns out to be the negative of the derivative of the arc cosine function. So we'll have negative 1 over the square root of 1 minus u squared times u prime. But here we are differentiating with respect to r, and we have only an r here. We don't have a function of r inside the arc cosine, so that's going to make our work a little bit simpler. Alright, so we will have the cosine of r times the derivative of the arc cosine, which again is negative 1 over the square root of 1 minus u squared, but u is r, times u prime. But we're differentiating r with respect to r, that's going to be 1. Plus the derivative of the second function, the derivative of the first function, the derivative of the cosine is negative sine of r, and then we'll have this times the arc cosine of r. We can clean that up a little bit and write it as negative cosine of r over the square root of 1 minus r squared minus the sine of r times the arc cosine of r. 1k, we are asked to differentiate y equals the inverse secant of x squared. But remember that inverse secant is just another way of saying arc secant. So if you like, we can think of this as y equals the arc secant of x squared. In fact, I think that's what I'm going to do. So what we have is the arc secant, and then we have another function placed inside the arc secant. So we have a composition of functions. We're going to want to use the chain rule. So we need the formula for the derivative of the arc secant function. So if y equals the arc secant of u, that tells us that y prime is going to be equal to 1 over u times the square root of u squared minus 1 times u prime, in the event that this is something more complicated than just x. And in this case it is x squared. So remember, this u prime is sort of, it's building in the chain rule automatically. Alright, so in our case we'll have as y prime 1 over, now our u is x squared, so we'll have x squared here, then we'll have the square root of x squared squared minus 1, and then times u prime, the derivative of u is 2x. Well, if you write that as 2x over x squared times the square root of x to the 4th minus 1, I think you'll see that you have a factor of x here that can go away. And so we'll write that as 2 over x times the square root of x to the 4th minus 1. For this section on integration, we're going to be using these 4 formulas fairly extensively. Here, in these 4 examples, a will represent a constant and u will represent a function. So if you've got the integral of 1 over the square root of a squared minus u squared, that's equal to the arc sine of u over a. You may not be able to read that very clearly, so I'm going to rewrite that again. Arc sine of u over a. And of course the constant of integration, if you're integrating 1 over a squared plus u squared with respect to u, that's going to be 1 over arc tangent. My arc tangent also looks a little funny there. That's going to be u over a plus c. If you've got 1 over u times the square root of u squared minus a squared with respect to u that you're integrating, it's going to be 1 over a times the arc secant of the absolute value of u over a plus c. And then the integral of a to the u du is a to the u divided by the natural log of a. 2a. We are asked to integrate 1 over the square root of 4 minus x squared with respect to x. Of these 4 forms, this looks the most like number 1. You've got 1 over, a is a constant, remember, so a squared is a constant, minus a function squared with respect to whatever variable. So in this case, this is the same thing as 1 over the square root of 2 squared minus x squared with respect to x. So here a is 2, and if you're using this formula, you would think of u as x, though I don't know that that's really necessary. You can just rewrite this as 1 over the square root of a squared minus x squared with respect to x, and then this would be arc sine of x over a. So if you just replace the u with an x, over here and over here, you'll be okay. If you just turn all the u's into x's, you'll be okay. Or you can do a substitution, whatever you like. So in this case, if a is 2 and u is x, du is the derivative of u times dx. So that's going to be 1 times dx, which is just dx. So what we've got is 1 over the square root of 2 squared minus x squared over dx, or if you like, 1 over the square root of 2 squared minus u squared du. And according to the formula, that's going to be the arc sine of u over a, which is going to be the arc sine of x over 2 plus c.